So what are the sources of radiation? Just to briefly go over those, right? Because I already have mentioned to you that we see quite a bit of radiation exposure just from natural background. So the average person receives about 620 milligrams per year. 50% of that is background, and 50% of that is man-made. And the man-made radiation is almost exclusively from medical sources. And in medical sources, CT is the major contributor to that. As a matter of fact, 50% of the man-made exposure approximately is from CT. So of the exposure the population sees, right, 25% of the total radiation exposure the population sees is from CT. Half of it natural occurring, half of it medical, and half of that medical half is CT, 25% from CT. So where are the natural sources? Well, some of it's from the soil, right? Some of it's from radon and thoron. Radon, unfortunately, when it decays, gives off an alpha particle, right? We don't worry a whole lot about alpha particles because they're so massive, right? They have 2 protons and 2 neutrons, and they have +2 charge that, frankly, if someone were shooting a beam of alpha particles at you, if you held up a piece of paper, it would stop those alpha particles. But unfortunately, those get liberated into the air. And when we inhale that air, right, they can then end up landing on the surface, the lining of the lungs, and those kind of things. So that's how our dose tends to occur from those. And unfortunately, in people in certain parts of the country, right, in their basements, there's some radon gas that's liberated through there, and people end up getting exposed as that decays and gives off those alpha particles. There's some extraterrestrial component, right? 5% of it comes from extraterrestrial. 5% or so comes from the food chain, potassium. So anybody who eats bananas, you're exposing yourself to some potassium-40 there. So what about the man-made? About 50%, as I mentioned. About half of that's coming from CT. Nuclear medicine's the next big player, interventional, and then radiography, fluoro, a smaller proportion. And then there's a small amount of other, industrial, occupational, consumer goods kind of thing. And here's a nice chart that kind of breaks down some of the sources. So look, the background from radon and thoron, right, is really the only thing that's bigger than CT here. But I want to make one point about this portion of this, and that is, yes, there is some variation in that. You know, if you decide to live in Colorado instead of living at sea level, your exposure to naturally occurring radiation is higher than it is. But this portion, the 50% that's medical, has a very different distribution. And in the days of HIPAA, I can't ask this question anymore, but I used to always ask something like, you know, how many people in the room had a CT scan this past year? Okay, because when you look at the radiation dose seen by the population, it's around on the order of every person in the country getting 1 CT a year. That's what the medical dose is. And yet, in the room, there would be maybe 2 or 3 people who would raise their hand and had a CT scan. And as radiologists, we've all been in the waiting room where we've pulled up the patient who's gotten their, 6th renal stone protocol CT of the year kind of thing, right? So there's a very unequal distribution of the medical sources of radiation. I think I mentioned all of these things before, just checking through there to make sure you've got those. Yes, and I mentioned this too, right? This 6.2 millisieverts. That's approximately the amount. This is the amount that we get from medical on average. That's approximately the amount of an abdomen pelvis CT. So like I said, if you took all the medical and you uniformly distributed it across the entire population, it would kind of be the equivalent of everybody getting an abdomen pelvis